Alright, so today we're going to be talking about counting, permutations, and combinations. Counting principle alone, number theory, is its own class in college, as well as permutations and combinations is also its own whole division of math. So keep in mind today we're really only going to be scratching the surface of these topics. This is just at the end of Algebra 2, we kind of go through several other variations of math just to give you an idea of what else is out there other than algebra. Because I feel like up to this point in your education, you're really focused on a lot of geometry and algebra, and you haven't really seen what else is out there. So keep in mind, you're not going to see this as a whole. You're just going to be looking at, like, you know, a more broad view of things. All right, so the first thing we need to address is what's called the fundamental counting principle. This rule is used to count the number of possible outcomes in a situation. If you have one event A with possible outcomes and another event B with possible outcomes, the total outcomes is the product of possible outcomes. So that is going to allow us to count different situations. So you go to Jersey Mike's and order a combo meal consisting of a sandwich, chips, and drink. There are 10 sandwich types, 4 chip varieties, and 6 drink options. So we want to figure out how many variations there are. So what you do is you put a slot for each scenario and you put a multiplication sign between it. How many sandwich options do you have?
10.
How many chip options do you have?
4.
And how many drink?
6.
So how many combinations?
Yeah,
240 combinations. So if you ever go to a customizable food place, like, I don't know, like I think the yogurt shops might say this sometimes, like the frozen yogurt, they'll like have on the wall, like, we have over 480 combinations. That's what they're doing, okay?
So that's like why the Nerf modules commercial says, like, we have over 1,000 combinations. Like,
That's literally what they're doing.
It's insane.
Alright, does anybody have any questions about example 1? Pretty straightforward.
Like, so if you order a different, just one different chip as a different combination or whatever, like, I hate that so much. Like, just tell us, like.
Yeah, like literally, like, they count that as every little thing. And some places will even count down to, like, if they have a sandwich with tomatoes or without tomatoes, like they'll count that as a
Oh,
sandwich.
bro, it's not that deep.
Or like with sauce or without sauce, like.
Yeah.
Ugh.
So Colorado is redesigning license plates to consist of 5 alphanumeric characters, with the first 3 characters being letters, 4th character being a number, and the last character being either letters or numbers. So you want to know if this is enough for the 1.7 million registered vehicles. Does it say anything about not repeating numbers or letters here?
No.
So it's okay to repeat.
So only one character number, so that's only the chip will have, or 1 through 9. Or is it 1 through 0, I guess?
We'll get to it, yeah, it's 0 through 9. So, firstly, we want letters. So how many letters are there in the alphabet?
26.
Good. And since we can repeat letters, what can the second slot also has how many options?
26.
Good. And the third slot? Exactly. So if it couldn't repeat, it'd be 26, 25, and 24. But since they can repeat, we have all 26 options for each slot, A through Z. Now, we're looking at this 4th, which is going to be a number. How many single-digit numbers are there?
9.
One more than that. 10, because we have to count 0. And the last slot is numbers and letters, which are 36. So that comes out to be, so that 36 really brings up the number. You'll notice a lot of states will have that extra one at the end that can be a letter or a number. That really brings up the amount of combinations. So that's 6,327,360. Is that enough? Definitely. So over time, you probably haven't seen this as much in your lifetime, but states where their populations increase rapidly, they'll have to actually add numbers, extra numbers to the end of license plates and whatnot to bring up the total. All right.
My friend has a license plate on one of her cars that is her last name, and the last name is North.
Well, that's like, you can definitely get a custom plate, and that's a whole other thing.
Right, but like, it's just, like, is that their actual license plate, or is it?
Mhm. Yeah, a custom plate works a little differently. You have to pay extra And also, like, it doesn't have to do with any, like, the random generic ones. It's just, like, that one's in a bank so nobody else can retake it, kind of like a username, in a way. Like on Facebook or something, or Instagram, you can't take the same username.
How many characters do you get per custom license plate?
I'm not sure.
I just want a custom license plate. I think it's a cool thing to have.
I think it is too. So, if we're dealing with a lock, like say we have a 3-number lock, so like one of those twisty ones for the bikes, and we don't care about repeating, how many choices do we have for the first number?
Is that 1, 2, 30?
No, like it's just single digit.
Is it like
So 10 times
10 times 10 times 10, right?
1,000.
1,000 combinations. So even with 3 numbers, there's still 1,000 combinations. You probably didn't like think that it's that many, but it's quite a bit.
It's not that, like, if it's a 3-number thing on a briefcase, you just try 0, 0, 0, 0, and 0, 0, 0, 1, and then spend like 4 hours of your day trying to open the
I mean,
briefcase.
that would take. This is even less though because
That'll take way too long.
non-repeating. How many choices do we have for the first one?
10, 9, and 8.
10, then 9, and then 8.
How is 10 a single digit number?
Because
No,
that's-
it's not saying 10 is a single digit number, it's how many single digit numbers there are. So if you count on your fingers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's, you get it? Now, it's not saying actually 10, it's how many numbers. So page 1 was pretty easy, pretty like stuff that you probably can do. Now we're going to get into a few more examples that require some new concepts, okay? So we're going to talk about a combination versus a permutation. These are methods we use to choose numbers based out of groups, okay? So like if I take a group of 16 students and I want to pick a group of 7 of them. Now, the main thing you need to know about a combination is order does not matter. If I pick a group of 7 of you guys, I don't care what order that you're standing in. You're all still the same group of people, right? A permutation is where order matters, so maybe like a lineup. Okay, if I want people in a certain order in a line, that's a permutation. Order matters versus order does not matter. So you have to determine in every scenario if the order matters or not to determine if you're going to use which formula you're going to use, basically. Now we have this thing in math called a factorial. And a factorial is an operation that multiplies out a number by its previous integers that come before it. Okay? So, actually it's technically the natural numbers because 0 is not included. So 4 factorial is 4 times 3 times 2 times 1. What do you think 5 factorial is? Yeah, you get the idea. So that's what a factorial does, and this is really useful in probability because you probably already have started to notice when we have non-repeating, we always go down by each number each time. So it's like a useful concept in probability. So let's talk about permutation and combination formula. Now permutations, there's always going to be more permutations than combinations. Because if I take 3 students out of the group of kids in this class, I don't care what order you're in, that doesn't count as many times as if I took those 3 students and then ordered you the 6 different ways I could order you. That's going to count as more than if the order did matter. So this is the formula we use. It's called NPR for a permutation and NCR for a combination. So if you have a group of 7 kids, okay, and you're choosing 3 of them, 7 factorial over 7 minus 3 factorial over 4 factorial. For the combination, it's 7 factorial over 7 minus 3 factorial, 4 factorial, then times how many you're choosing. Now the cool thing is, there are calculator functions that do all this math for you, so you don't have to do the longhand math. I'm going to show you how to do it once just so you see it, but then I will show you how the calculator can do all of this for you. So we all know that we can calculate 8 factorial by just multiplying 8 by all the numbers that come before it. And that would be one way to do it. But here's what's cool about Desmos. If I pull up my Desmos calculator, I try to zoom in so you can see the buttons a little better. If you click on the function button, you see these last 3 buttons on Desmos right here. These are the problems for permutation, combination, and factorial. So if I go and I click 8 and then I hit the factorial button, it does that math for me in the calculator.
It's just the exclamation point.
just an exclamation point. So you're gonna see a lot of jokes like online when they talk about they'll say an exclamation point at the end of like a number, like as in a sentence. People like joke about it being like, you know, what this is. So yeah. So that's 40,320.
That is, so all this math calculator does for me?
Yep.
Do I have to write out 8 times 7?
No, that was just for me to help you understand what it was doing.
This looks good this time.
So this is 7, you have a group of 7 and you're choosing 3, and the order doesn't matter. So this is a combination. Now to do a combination by hand, it's the first number, exclamation point, factorial, over the difference of these two numbers, 7 minus 3, which is
5.
4.
4.
And then times, that bottom number's times whatever this first number is. That's how you do it out by hand. Okay, if you wanted to do it without a fancy calculator. Because like back when I did it, like I wasn't allowed to use a calculator, so this is how I had to do it, but you guys are, so this is how you can do it the easier way.
You weren't allowed to use a calculator for this?
No, so in my degree, like you're not allowed to use a calculator at all, which is like good and bad because like my math's really good, but also I don't know how to use a lot of things on calculators. I have to like teach myself how to do it.
Dude,
So
that's tough.
That's terrible.
Especially for this, that's so tedious.
this is not even comparative to that being tedious as some other things are. So you would do this in the calculator, but an even cooler way to do it is I'll show you now. So this is how you would do it like out by hand in your way, and you should get 35. But here's what's cool. You see on the calculator they have a button for NPR and NCR. You can use those as well. So since it's a combination, we're going to hit that combination button, NCR. Now you're probably wondering, how do you actually use this operation? Well, what you do is you type in N, which is 7, and then you hit comma what R is. Okay, that's how you type it in the calculator. Now I'm just going to be really clear with you guys. If this comes up on your test, and you come to my desk and you say, I typed this in, but I don't know why it's not working, I can't tell you that. So you guys have to know to put that comma in there. So if you want to write a note, do what you got to do. I'm trying to be really clear with you right now about it. Make sure you know how to type this in the calculator. N, comma, R. That's how you type it in. Okay? All right. So that's 35. Now we're going to do a permutation. So these are the same type of idea. You have seven items, people, whatever it may be, and you're choosing 3 of them. But here order does not matter. Here order does matter. Okay? So with a permutation, you do whatever that first number is factorial over the difference of the two, factorial. You don't have that extra r factorial on the bottom. And this would come out to be 7, 8, 9, 6, 24. I think it's 210. So here's how you would do it on the calculator. So what's really cool about Desmos, and I always say work smarter, not harder, and save your time, you can go back in and edit old problems, right? Old calculations. Can't I just take out the 3 factorial? And can't I just change the C to a big P? Saves you time. Now if you wanted to, you could do it fresh, like hitting that button and then typing it in as well. Okay? So now that you have the general idea of how to do these calculations, yes.
Is 4 always a denominator? Like one of them?
No, it's 7 minus 3. That's how I got 4. So if the numbers weren't 7 and 3, it wouldn't necessarily be 4.
Okay.
But so how did you get the 3 if it's not in the equation?
It is in the equation.
Oh, okay.
Yeah. The 4 isn't, but the 3 is.
Okay.
How many baseball teams of 9 members can be formed from 14 players? So does order matter here when choosing them? No, so this is a combination. So once you have a team decided, we don't care what order you pick that team in. It's still the same team whether or not you pick somebody first or somebody second or third, you know what I'm saying? So this is going to be 14, choose 9. Now the number in the front will always be bigger than this number because you can't pick a group of 9 people you can't pick a group of 14 people out of 9 people. That first number has to be bigger. So that's like your pool, and you're picking from that pool. So like I said, calculator can do all this work for you. change this to a C, change this to a 14, and change this to a 9, and you get 2002. So you don't have to write it out as a factorial every time. I just wanted to show you where this math comes from, how it's actually calculated. Because I don't want you to just get used to seeing like, oh, I'm just using this formula. Like, I don't know what the calculator is doing. It's important that you understand what's going on behind the calculator. You know what I mean? Okay. So 9-player batting lineups you can create from a team of 18 baseball players.
Is the bigger number always going to be first?
Yeah, that's what I was saying, yeah. It has to be because you can't pick from a pool that's smaller than what you're trying to pick. Batting lineups. Does order matter for a lineup?
Yes.
Yes.
Yes. That's a permutation. Because order matters if we're specifically picking lineups. Because I could take the same 9 people and line them up in a different way, and that would change the lineup, correct? So you're doing 18P9. So I change this to an 18, and I change this to a P. Oops. See, if you do it lowercase, it doesn't work. Has to be uppercase. Okay, very important. I'm gonna write it out for you. Don't worry. So it's gonna be 1 7 6 9 3 2 2 5 0 0 because it's in scientific notation, so I just converted it back into normal form for you. Oops, I put it in the wrong spot.
So that's a scientific calculator you're using?
Yes. So that's 17 billion.
You skipped a 6. You said 5 0 0.
Did you say 9?
I said it
You
when
said
I wrote
9.
it.
Yeah, you said 9. Was this supposed to be like 4 whatnot? Or
What's going? Wait, you guys are all talking at me at once. Wait, what?
Can you tell us the number again?
This is the number. It's on the board. That's correct. I was gonna read it out now. 17,643,225,600. That's correct. If I said something else before, that wasn't what I was saying.
Thanks.
You're welcome. I flip my numbers upside down sometimes when I go to say it out loud, so. But yeah. Would you have thought there was over 17 billion ways to do this?
No.
It's crazy.
That's more ways than there are people in the world.
I know, that's why it's, we don't realize the power of like how many combinations of things there are that can happen. It's actually wild.
That's why it's so hard to guess
It is. Alright, so I'm just going to tell you guys that 10 and 11 are important for the test.
So that means I can now calculate really, like, I really hate when a website makes me use a number and an uppercase letter and because that it makes me really upset because the password I normally use is all lowercase letters.
We can actually at the end of class, if you want, I can help you figure out what the chances of somebody guessing your password is. So
I just want to know like how many more ways is
no, I got you. So this question right here, so you guys want to know about this one because it is on your test, okay? So the first thing you want to notice about the word they're asking you to rearrange, first thing you want to identify is, are any of the letters repeating in this word, yes or no? No. So there are 6 unique letter slots, correct? So for the first letter slot, you have 6 choices, right? You have O, R, A, N, and G to choose from. For the second slot, you have how many choices?
6.
5, because you already used a choice. Now you use 2, so you have 4. Now you use 3, so you have 3 left. Now you use 4 choices, so you have 2 letters left. And now you have whatever letters left. So isn't that the same thing as 6 exclamation or factorial? So all you have to do when you want to figure out how to order a certain number of a word a certain number of ways, it's always however many letters there are factorial if there are no repeating letters. Okay? Now we're going to do one with repeating letters, of course. So here's how you do it with repeating letters. Step 1. Count the number of letters in the word. How many are there?
1, 2, 3, 4, 5, 6,
10, 11, 12.
12. So the numerator is 12 factorial. However many letters there are factorial. the denominator is based on the repeating letters. I have a repeating t. How many times does the t repeat? Whatever, how many times it repeats? 2 factorial on the bottom. Then we have a repeating O. How many times does it repeat? 2 factorial. Then we have a repeating R. Repeats how many times? 2 factorial. So if it repeated 3 times, you would do 3 factorial. Now you just put this in the calculator. What is 2 factorial? 2. So, yeah, it's really just, the denominator is just 8, isn't it?
Yeah.
So if you can fast track it if you want, I just want to explain that to you. So if I were to just like be doing this on my own, like when I make a key or something, not in front of everybody, I would just in my head do this. You know what I mean? So you don't have to. I just want to explain to you, not all math has to take an hour to do. I just explain it as thoroughly as possible when I'm doing it with you guys. Because 2 factorial is 2 times 1, 2 times 1, 2 times 1, that's 2 times 2 times 2, which is 8. So there are 59 million, I will write it over here, don't you worry. 59,875,200 ways to rearrange the letters in trigonometry. So I just want to like help you understand the magnitude of this real quick with an example, because I don't think we really think about it. So,
My face is gonna melt.
how many 5-digit whole numbers between 56,000 and 59,999 can be formed if no digit is repeated? So we're talking about numbers like 56,234. You know what I mean? Numbers that exist between those numbers that don't have any repeating digits. So each one of these boxes represents one of the 5 digits, because we know all numbers between these two numbers are going to have 5 digits, correct? The first digit for any number between those numbers is going to have to be what?
55.
The very first digit has to be a 5, right? Because it's going to be between those two, it's going to be a 5. So there's only one choice for that first number. It has to be a 5. Now as for the second digit, if it's between 6 and 9, we have, it could be a 6, it could be a 7, it could be an 8, or it could be a 9, correct? So there are 4 choices. Now for the next one, it can be anywhere from 0 to 9, so that's 10 digits, except for there's one problem. How many digits have we already used?
2.
So it's actually 8. For the next one, same idea, it can be anything, but we've already used how many digits?
3.
So it's,
7.
and then lastly, it's the same idea, it's just 6. So that's 1,344.
You did that in your head?
No. I just memorized it from last period.
Oh, it was.
I mean, you can, it's not that bad. So what I would do, well, I'm going to go off on a tangent, let's not do that.
Do it. No, do it.
What I would do in my head is I would multiply these together, so 32, and then I'd multiply 42, and then I would multiply the 3 and the 4, which I know would be 1,200, and then I'd multiply the these two, and then you just go through and do it each way. So you'd multiply the 2 times the 3, so that'd be 60, plus the 2 times, that'd be 80, and then you would do, so you would just go through and do each one of those on the list, basically.
It's pretty sick, actually.
So, do you guys know like area model that you do? Box method, whatever? You can do box method with multiplying multiple digits. So you can do 32, so it'd be 30 and 2. And then you can do 40 and 2. Multiply these and then add them together. Anyways, not useful, but sometimes it is. How many 4-digit numbers can be formed if the leading digit cannot be 0 and no repetition of digits is allowed? So if the leading digit can't be 0, it can be any number except for 0, and how many choices would that be? 9. Can the second digit be 0?
No.
Who said? Yeah, it can be 0. It can be anything except for what digit? The second digit. Anything except for what we picked for the? So how many choices do we have? 9. Because it can be 0, but it can't be whatever we just picked on the last one. And then the next one can be anything except for what we picked for the first 2, which would be 8. And the next one would be 7. So that one's tricky because they're both 9, so a lot of people mix that one up. So any questions about that one? Alright, now we're going to talk about how we use combinations to calculate probability in a way. So, you guys all remember the AND principle, right? With AND we use what? Multiplication. You're going to see that come up in this problem. So, how many committees of 3 men and 3 women can be formed from a group of 10 men and 8 women? So firstly, we have 10 men to choose from, and this is a combination because we don't care about the order they're picked. We have 10 men to choose from, and we're choosing how many? 3. Times, because remember, and we have women to choose, correct? And we have 8 women, and we're choosing how many? 3. So if you do this math in the calculator, you get this. Now, why would this not work? I have 18 people, and I'm choosing 6. What's the problem with using this?
Not choosing from a group of 18.
Well, I am choosing from 18 because I have 10 men and 8 women. So why can't I just do that?
Because there's different genders, like there's 10 men.
Yeah.
Because if I do this, couldn't I pick all women or all men, and that wouldn't
Yeah,
be what we
basically.
wanted? Yeah, so just keep that in mind when they separate it like that, when they want a specific amount of each one, you have to make sure you have them as 2 separate calculations, okay? So that's just like, this would give you the right number of picks. It would give you 6 people. They just might not be the gender distribution that you wanted. Okay. I'm just going to give you a disclaimer on this problem before we start.
Is it hard?
It's not hard, but it's like one that you have to kind of think about. So I don't want you to be discouraged by it if you don't understand like right away. This is not going to be a problem I'm going to ask you on the test, okay? So, how many ways can 5 movies be rented from 8 westerns and 12 sci-fi movies if you want at least 2 westerns? So we're trying to figure out the total number of ways this can be done. So, OR. There's a lot of ORs involved. We know that OR involves what operation? Plus. So you're going to see some pluses going on here. We have an OR and an AND combined into one. You're picking westerns and sci-fi. Those are going to be multiplied, plus whatever other situation can occur. Okay? So if you want at least 2 westerns, that means you're okay with having 2 westerns, 3 westerns, 4 westerns, or 5. Because remember, you're picking 5 movies total, and you want at least 2 westerns. So you're okay with any of those 4 things happening.
So that'll be 5 factorial.
No, it's way more complicated than that. So for the sake of this problem, I'm going to do all the western calculations in blue, and I'll do all the sci-fi in pink so you can kind of keep track of them. So first and foremost, I have 8 westerns to choose from, correct? Would you all agree with that?
Yes.
We don't care what order, and then if I want to choose the minimum amount of them, I can choose 2, correct? But that means I need to fill the other void with the other movies I need to fill with sci-fi, correct? So how many sci-fi movies do I have to pick from? 12. And to fill up to have 5 movies, I would choose how many? 3, because I already choose 2 westerners. Okay. Or, it's addition. Or this is what the other thing I could do. That's one way to do it. Here's another way. Can't I also take the 8 western movies and choose 3 of them instead? And that would mean I would have 12 sci-fi movies to pick from, and how many would I be picking? 2. Or,
Oh boy.
Oh my.
can't I also have 8 western movies and choose 4 of them? Because that would give me the 4, at least 2. Which would mean I'd be picking how many sci-fi movies?
1.
Good. And then lastly, can I just pick all westerns? Wouldn't that be okay? Because we want at least 2, right? Which would mean I'd be picking how many sci-fi? 0. So for that reason, if you do all this in the calculator, you just put it into Desmos. Don't hurt yourself.
Oh my goodness.
I'm just going to tell you what it is.
Yeah.
So here's the cool thing about the strategies you've learned today. You can apply these to real life scenarios. Some are going to be harder than others. Some are going to be tricky. You're going to have to work your way through them. It's tricky sometimes. There's inevitabilities that you forget about. You'll double count things. But the whole idea is these are principles that you can use to apply to real life scenarios to count things. So you have the rest of the period. I just want to mention to you number 1 is a combination on the homework, because if you have a hand of 7 cards, does it matter what order that hand is in? Is it the same hand as if you rearranged it? If you took 7 cards and you had them in your hand, you can rearrange them as much as you want, right? When you have so that's a combination. Okay, 52 choose 7.